Hi folks, we're going to take a look at page 326, number 16. So here they're asking us to find the unit vector that's in the direction opposite to the vector PQ if OP and OQ are equal to these vectors here. And remember what this means is just the vector that goes from the origin to the point P, which in this case here would be 11, 19, and here 2, negative 21 for Q. So before I start, I just want to remind myself that if I'm looking for a unit vector, it means that my final answer has to be a vector with magnitude 1. Okay, so let's look at the characteristics. So we need the direction opposite to PQ. So I can first find PQ and then take the negative of that, or just find the opposite of PQ, which is QP. Okay, so let's find, just so that we can see a couple of steps here, let's find the vector PQ. So this represents the vector that starts at point P and ends at point Q. And the way we think of it as a subtraction of these two vectors, the vectors to each of those points. And remember that we do the second minus the first. So here this is going to be OQ minus OP. All right. So this is just 2, negative 21 minus 11, 19. And so that gives us, well, 2 minus 11 is negative 9, and then negative 21 minus 19, that's negative 40. Okay, but we're not interested in this direction. We're interested in the direction opposite to this. So we're actually interested in QP, and that's just the negative or opposite of this vector. So that's 9, 40. Okay, but now we need to go further because we want the unit vector in this direction. And the way in which we find a unit vector in the direction of a given vector is by just dividing by its magnitude. Okay, so if I'm looking for, say, and I'll use the hat notation, so the unit vector in the direction of QP, well, that's just going to be equal to 1 over the magnitude. Okay, so the magnitude here is square root of 9 squared plus 40 squared, okay, times the original vector, okay, which is equivalent to taking the vector, dividing by the magnitude. All right, so let's, and I think in the question they actually asked for the components, so let's make sure we find the components of those vectors. So here, let's take the square root of 9 squared plus 40 squared. Okay, it's exactly equal to 41. Okay, so it's 1 over 41 times 940. All right, and then here, if we want to write it as a single vector, let's just distribute that scalar multiple. So it's the vector 9 over 41 and 40 over 41. All right, so this is in the same direction as QP, which is what we were looking for. We know that because we multiplied by a positive number. Okay, and if we want, we can even just check, if you trust the math, you don't need to, but let's just check that the magnitude of this vector is indeed equal to 1. Okay, so let's take the magnitude of the vector. So magnitude, so square root of, so first squared plus second squared. So 9 divided by 41 squared, and then plus 40 divided by 41. Whoops, 41 squared. And we see that the magnitude is equal to 1. All right, so just to review here. So again, very important to understand how to take a vector and turn it into a unit vector in the same direction. It's all about dividing by the magnitude of that vector. But first we had to find the direction we were looking for. So we found PQ, and then it's up opposite. And then from there, we were able to find the unit vector. All right, that's it for this one.